Now that we have a good introduction to hypothesis testing, let's talk about two types of errors that we can make whenever we conduct hypothesis tests. The first type is known as a type 1 error. Type 1 errors occur when we reject the null hypothesis when the null hypothesis is actually true, right? So remember, our null hypothesis is what we assume to be true, right? And so if we reject it and conclude our alternative when the null is actually true, we have actually made an error, right? And so that is what a type 1 error is. And the probability of making a type 1 error is equal to alpha, which is our significance level, right? So whenever we're doing research, when we set that significance level before we conduct our hypothesis test or at the beginning of the study, we're also setting our type 1 error rate. Type 2 errors come from failing to reject the null hypothesis, right? Remember, we do that when our p-value is greater than our significance level. But if we fail to reject the null hypothesis, and in reality, that null hypothesis is actually false, of course, we want to fail something, we want to reject something that's false, right? But if we fail to reject that null and that null is false, we are making another error, and that error is your type 2 error. All right? The probability of making a type 2 error is beta. So beta is the probability of making a type 2 error. Now, we don't usually set beta for our study, but we set something related to beta in our study. And so, what I'm going to actually do is I'm going to skip over a slide and I'm going to go ahead and talk about the thing that's related to beta. Because I already said in that last slide, alpha is the probability of a type 1 error. And we usually set that type 1 error rate before we conduct our study. That's our significance level. Well, beta is our probability of our type 2 error, and we don't usually set this at the beginning of a study, right? What we usually explore at the beginning of our study is something related to beta, which is called statistical power. Actually, I'll continue with my slides as normal, and we'll get the power later. Before we get to statistical power, let's talk about summarize this in the possible outcomes table for our hypothesis test, right? So in the columns here, I have the truth. Now, in reality, excuse me, in the same way that we would never know the value of our population parameter, usually, we don't know whether H naught is true in reality or H naught is false in reality, right? We just gather data, use probability and uncertainty to come up with a decision to reject or fail to reject, right? But there's a true situation in reality that we do not truly know. But let's suppose that we do know in some cases that H naught is true or H naught is false, right? These are our two scenarios here. And then, of course, whenever we do a study, we are either going to reject the null or fail to reject. Well, if we reject the null and the null is actually true, we've actually made that type 1 error. That's a bad decision there, right? We've made a type 1 error. So where these two cross paths is our type 1 error. If we reject a null when the null is in fact false, that is something that we want to do. We want to reject a false null hypothesis. So that is a correct decision. All right. So whenever we reject the null hypothesis, we're either going to make a type 1 error or we're going to make a correct decision. All right. When it comes to failing to reject the null, if we fail to reject the null hypothesis and that null hypothesis is actually true, yeah, we don't want to get rid of we don't want to get rid of the truth, right? So we want to fail to reject. That is a correct decision there. And then last but not least, if we fail to reject the null, given that the null is actually false, we want to reject the false, right? We've made a type 2 error. Okay. So we want these type 1 and type 2 errors to be small. That is why when we looked at our alpha being our type 1 error rate, we set it to a small value, a small probability of like 0.05. A type 2 error, we also want that to be small, but we don't necessarily focus fully on that type 2 error. We focus usually on statistical power. Now, what is statistical power? It is basically the complement of a type 2 error. It's the power, it says power of a statistical test is 1 minus beta. If you think about probability or in probability terms, 1 minus a probability is represents the complement of something. But the if I take 1 minus the type 2 error rate, I would equal or get a value equal to statistical power. It is the probability of rejecting the null given that the null is false. All right. Um, this is a value that we want to be high in educational and a lot of social science research. We want the value of statistical power to be at least zero point 0.8 or 80%. All right. If I go back to that previous slide there, power is in this cell of this table here, rejecting the null when the null is actually false. All right, that's the power of the test. Is this hypothesis test going to be powerful enough to actually detect that something's happening in our data, right? That's why we get that term power from. All right. One of the things that we want to know just for this section are for now related to type 1 and type 2 errors is how to identify the type 1 and type 2 errors in a study, right? And so I have this study that we've already looked at before. It's about that new reading program that a school is implementing. I guess you can think of it like a pilot study or something. They're hypothesizing that students that are participating in the program in general will have a score that's beyond the national benchmark, right? And if they can generalize that, they'll probably implement it in more classrooms itself, in addition to that single class. So we already saw in our last video that we said our null hypothesis was mu equals 75. Our alternative hypothesis is mu is greater than 75, that national average. So I want to identify a type 1 and type 2 error, right? Well, remember your type 1 error is a rejection error. You're incorrectly rejecting the null. And your type 2 error is a failure to reject the null error, right? So type 1, rejection. Type 2, failing to reject, right? So if I'm going to interpret my type 1 error, I just said it's incorrectly rejecting your null. It is very similar to coming up with a false positive. You can almost think of diagnostic test. If it detects a disease in your body, you're going to have a positive result, right? And so in hypothesis testing, rejecting a hypothesis is akin to a positive result. You're detecting something in the data. But since we are incorrectly rejecting, and when we do a type 1 error, that's a false positive result when it comes to like diagnostic testing. I just wanted to make that connection or parallel for you. All right. But the actual interpretation of this type 1 error is that we would reject the null and assume or conclude that our alternative is true. That, oh, students who would participate in this program in the population would have a score higher than the national benchmark, right? So we can conclude that that new reading program actually has an impact on those test scores when it actually doesn't in reality. That is a type 1 error in this case. A type 2 error, remember, we incorrectly fail to reject the null, right? So we will fail to reject the null. Some people used to say accept the null, right? But we're incorrectly doing that, right? Well, failing to reject is akin to having a negative test result. That means the diagnostic test for seeing if someone has a disease in their body, it comes out negative because it didn't detect anything. When we do a hypothesis test and we fail to reject, we didn't detect enough evidence in our data to say that something's there, right? So it is a negative result. However, we've incorrectly failed to reject. That is why we have a false negative here. So a type 2 error is like a false negative, right? But the interpretation, we would be concluding that the new program has no effect when it actually does, right? So we would kind of say, oh, well, this null hypothesis may still be true. We just haven't gathered enough evidence. It may still, my null may still be the case, when actuality, it actually is not the case. And so that's our type 2 error, right? Now, which one of these is more detrimental or may have more impactful results, right? Well, if you think about this type 1 error, concluding that the new reading program affects test scores when it doesn't, that has the potential for the school making a decision to adopt that program when it doesn't actually impact reading skills whatsoever. So they may be wasting their funding on something that actually doesn't work, right? If I think about this type 2 error, what's the impact of that? Well, the school might miss out on a program that actually improves reading skills if they use the results based off of the scenario with the type 2 error, right? But ultimately, remember that a type 1 error is incorrectly rejecting the null. Type 2 error is incorrectly failing to reject the null. And then you think about your interpretations that way. All right, that is it with the errors when we conduct hypothesis tests. In our next video, we're going to get to confidence intervals, which is another statistical inference tool. We'll see you in the next video.